Alright, so the first thing we're going to do is write down a theorem. This is something that we know to be true. So this is the conjugate zeros theorem. If you have a polynomial with only real coefficients, so the original polynomial doesn't have any i's in it, then if one complex number is a zero, so is the conjugate. Forgotten, when I ask for the multiplicity, that's the number of times the zero occurs. We've seen multiplicity 2 several times. We can have higher multiplicities. So if you have something that is a multiplicity multiple times, so the same zero multiple times, then we say it has a multiplicity. Okay, so the conjugate zeros theorem is very, very important here because it tells us that as long as the original polynomial doesn't have any i's in it, any imaginary zero you have comes in a pair. So if 2 plus I is a zero, so is 2 minus I. If 3i is a zero, so is negative 3i. So the conjugate is also going to be a zero. So do we have this stuff down? So let's look at this first example. I want to create a polynomial where the zeros are 3 and 4 plus I. But the thing we have to realize here, even though I didn't tell you that, if 4 plus I is a 0, what else has to be? 4 minus I. So this polynomial would have to be at least degree 3. So my polynomial, if 3 is a 0, what's my factor? If 4 plus I is a 0, you have to distribute the negatives, so it'd be x minus 4 minus I. And if 4 minus I is a 0, so you do x minus 4 plus I. We could multiply this whole thing out. If we do, those i's would cancel because they're conjugates. We know that from, we've seen that happen before, like if we're trying to remove an I from the denominator of a fraction, we would multiply by the conjugate, so it would drop out. But I'm going to let you leave these in factors, so you don't have to write or multiply it all out. So you guys do the next one. We have x plus 2. If 5i is a 0, then we do x minus 5i. If negative 5i is a 0, that's x. Okay, if negative 1 minus I is a 0, that's x. And if negative 1 plus I is a 0, we get x plus 1 minus I. You notice the only difference is the I term. One's positive and one's negative. The rest of it stays the same. So this one had to be at least degree 5. Questions? Let's try another. So I want a polynomial of degree 3 with the following requirements. So, if my degree is 3, how many factors should we have? 3, right? The degree is the number of factors. Are there any others that we have to add to the list here? No. So if negative 3 is a 0, what's my factor? If negative 2 is a 0, and if 5 is a 0. Okay. So that takes care of the degree and all the zeros. But now we have another piece. It says f of negative 1 equals 6. What is that telling me?
If you plug in negative 1, you'll get 6.
Okay. If I put in negative 1 right now, negative 1 plus 3 is 2. Negative 1 plus 2 is 1. Negative 1 minus 5 is negative 6. Does that equal 6? No. The only other thing, I can't add any more x's because my degree is 3. But we could have a number in front, couldn't we? So let's call this a for a second. And I know this whole thing has to equal 6. So if I multiplied it, I would have negative 12a equals 6. If you divide by negative 12, then my a is negative 1/2. So this polynomial has a coefficient of negative 1/2. That was the only thing I could change. Questions on that? So let's look at the next one. 4 is a 0 of multiplicity 3. So what would I have to put? If 4 is a 0, we have, right, we can write it 3 times, or we could just put it to the 3rd power if we wanted to save some time. And then f of 2 equals negative 24. So we have to find the coefficient here. So we know if we plug a 2 in, 2 minus 4 is negative 2 to the 3rd, and that has to equal 24. So we need to figure out what this coefficient is. So we would have negative 8a equals 24, divide by negative 8, so we get negative 3. Any questions on those? Do we need any more problems like this? So let's do some a little more like what we were doing last week. We knew that if you had the first 0, we would start out by dividing. The difference, I said last week, I meant Monday. It just seems like it was last week. So we would start out with synthetic division until we got to like a quadratic, and then we could finish factoring it nicely. So if my polynomial is given, and I'm going to tell you that 3i is a 0. I want all the complex zeros. When I say complex, that means they could be real numbers, they could be imaginary. We're just finding everything. How many zeros should this one have? 4. How'd you know? count the x's here because they were all written. It's just your degree. Your highest power of x tells you how many zeros you're going to have. So like a quadratic is x squared, and we always got 2 zeros. Monday we were using cubes for everything, and we always got 3 zeros. So in x to the fourth, we should get 4 zeros. If 3i is the first one, we're going to do synthetic division with a 3i. Leave yourself, space this out a little more than you're used to. It's going to be a little bit uglier. Okay, we know that if it's a 0, what should we get for the remainder at the end? 0. So the 1 comes down. 1 times 3i is 3i. Okay. Can you add negative 1 plus 3i? Now we're back to multiplying. So negative 1 plus 3i times 3i. So 3i times negative 1 is negative 3i. 3i times 3i is 9i squared, which is negative 9. So when we add like terms. A 10 and a negative 9 is a 1. We have a minus 3i. So now we multiply. We're doing 3i times the 1 minus 3i. So 3i times 1 is 3i. 3i times negative 3i would be negative 9i squared, or positive 9. When I add, those 9's drop and we get a 3i. 3i times 3i. Okay, so I can put my x's back with this if I wanted. That's for my remainder of my constant. This would be my x squared, x cubed. Is this something we can factor nicely? No. But if 3i is a 0, what else has to be a 0? Negative 3i. So what we can do is synthetic division a second time with negative 3i and the answer we just got out. So you don't want the remainder, but we pull down the rest of these coefficients. When we're dealing with these i's, the first synthetic division is your ugly one, where you have all those i's appear. The second one should be nice. All the i's should disappear. So 1 comes down. 1 times negative 3i. If we add those, we get negative 1. Negative 1 times negative 3i. Positive 3i. If we add, those cancel and we get 1. 1 times negative 3i is negative 3i. Add and those give me 0. Remainder constant x and x squared. So we're down to x squared minus x plus 1. My directions on this one. Remember, if I'm asking you to factor, factors have x in them. If I'm asking you for zeros, zeros are just the numbers. On this problem, I said find all zeros. Does this factor nicely? So how do I get my zeros from that? Yeah, if it won't factor, we can do the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So 4 and negative 3. So I would have 1/2 plus or minus I radical 3 over 2. So my directions were to find all zeros. We knew it was x to the 4th, so we should have 4 zeros. So we have the 1/2 plus and minus I radical 3 over 2. That's 2 zeros. 1/2 plus this and 1/2 minus this. What are the others?
3i.
3i and negative 3i. If I asked for the factored form, you would have to do x minus each of those. If I had just said, give me the remaining zeros, you would not have used the 3i because I already gave you that one. You would have told me the other 3. So the process is the same in all of them. You just have to figure out how I'm asking you to answer the final question. You guys ready to do one? Here's your one. So first step is what? Synthetic division with the negative 2i. You do have to be a little bit careful. There's some missing powers of x, so you need zeros. So 1 comes down. 1 times negative 2i is negative 2i, plus 0 is negative 2i. Negative 2i times negative 2i is 4i squared, or negative 4. Negative 2i times negative 1 is 2i. And then that would be a negative 4. Sorry, positive 4. Negative 4i squared, which is positive 4. But since negative 2i was a 0, we also know positive 2i is a 0. So we do this again with the answer we just got out. You drop off the 0 because that was just the remainder. So 1, 2i, that adds up to 0. And so that's my remainder, my constant x and x squared. So we have x squared minus 1. And what does that factor into?
X plus 1, x minus 1.
So my directions were to find all zeros. So if x plus 1 equals 0, that gives you a negative 1. If x minus 1 equals 0, that's a positive 1. And then we also have the positive and negative 2i. Plus and minus 1, plus and minus 2i. Just as a review, I didn't ask for it, but if I said the factored form, that would be the x plus 1, x minus 1. What else would we have?
X plus 2i, x minus 2i.
So factored form has the x's in it, zeros does not. Is that okay? Let's try one more. Find all the zeros of this polynomial given that 1 minus I is a 0. So we'll start by dividing by 1 minus I. We have all of our coefficients. So 1 comes down. 1 times 1 minus I is 1 minus I. When we add, negative 7 plus 1, so we get negative 6 minus I. Now, we need to take 1 minus I times negative 6 minus I. So what do we have to do? Well, minus I plus 6I plus I squared. I squared is plus negative 6 would be negative 7. Negative I plus 6I is positive 5I. So adding like terms. 18 plus negative 7 is 11 plus the 5I. So multiply. 11 plus 5I minus 11I minus 5I squared. Negative 5I squared plus 11. 5I minus 11I is negative 6I. This is getting pretty ugly, but we know that we should get a remainder of 0, so it should clean up here. So negative 22 plus 16 is negative 6 minus 6I. So 1 times negative 6 is negative 6 minus 6I plus 6I plus 6I squared. 6I squared is negative 6 plus negative 6 is negative 12. Positive 6I and negative 6I drop. Alright, that one was significantly uglier. Are there any questions on what we did? If you slow down, take your time, it's all stuff we've done before. Multiplying with those imaginary numbers, adding like terms, stuff you've done, it's just a lot in one problem. But since 1 minus I is a 0, what else has to be? So we take the answer we just got, leaving off the remainder. So 1 comes down. 1 times 1 plus I. We add negative 6 plus 1 is negative 5, and the i's drop. Negative 5 times 1 plus I. 11 and negative 5 is 6. Positive and negative 5I drop. 6 times 1 plus I. And don't put drop and you get 0. So we are left with x squared minus 5x plus 6. How does that factor? So my directions were to give all the zeros. So we have 1 minus I, 1 plus I. If x minus 2 is a factor, your 0 would be positive. And if x minus 3 is a factor, our 0 is positive 3.
Are we able to know about plus or minus?
Yes. You could write that as 1 plus or minus I. That would be totally fine. Any questions on that? So I'm stopping here today. Is everybody